بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين سيدنا محمد صلى الله عليه وسلم. Dear students of the first grade secondary, this is your teacher Mahmoud Hassan, math teacher in Awad Abha Schools, the Egyptian section. It's my pleasure to teach you our lesson today of geometry. Unit 3, lesson 4. It's about applications on vectors. Firstly, we will study today geometric applications, and we have here some notes. The firstly is if ABCD is a quadrilateral in which AB vector equals K times DC vector and K not equal to 0, then AB straight line is parallel to straight line DC, and also the norm of AB vector equals the modulus of K times norm of DC vector and vice versa. That means uh, ABCD is a trapezium if K not equal to positive or negative 1. And we have here some examples to identify that rule. We have here example 1 saying using vectors prove that if two opposite sides of any quadrilateral are parallel and equal, then the other two opposite sides are parallel and equal in length also. And the quadrilateral is a parallelogram. Let's see how to prove that. We have drawn here a figure. Seems to be a parallelogram. It's named by A, B, C, and D. To follow the requirement, we assume that BA vector and CD vector are equal. So, since BA vector equals CD vector, where BA vector we have here BA starting from B going to A plus AD vector equals BD vector. Then we have here BD vector equals BA vector plus AD vector. And also we have here CD, a part of triangular rule of addition of two vectors like BC vector plus CD vector equals BD vector. So we say BC vector plus CD vector equals BD vector also. So we have here two rules. The first, BD equals BA vector plus AD and BC plus CD equals BD also. Then BA vector plus AD vector equals BC vector plus CD vector. And since BA is equal to CD, we can cancel them from here and here. Then AD vector equals BC vector, and that is the required, because we have here the note which say that if ABCD, as we know that earlier, is a quadrilateral in which AB vector equals K times DC, then AB is parallel to CD, That means here that AD is parallel to BC, and also AD equals BC, and that is the required. Also, he required that the quadrilateral is a parallelogram, and we know previously that the parallelogram has each two opposite sides are parallel and equal in length. So AD is parallel to CD, and AB equals to CD, then ABCD is a parallelogram. So we can say here in addition that ABCD is a parallelogram, and that is the required second. Let's move to example 2. We have here another requirement saying that using vectors prove that a line segment drawn between the two midpoints of two sides in a triangle is parallel to the third side and its length is equal to half of this side. We have drawn a triangle with this given, so we can start to prove that. We can say that since AB vector plus BC vector equals AC vector, then we have here AB vector plus BC vector equals AC vector. We can say it by this note: AB vector is equal plus 2 BC vector equals AC vector. So we have here a rule makes the sum of two vectors equals the third vector, and also AX vector equals half AB vector, and AY vector equals half AC vector. So we can multiply both sides of that note, one, multiplying 1 by half. So we have here half AB vector plus half BC vector equals half AC vector. And now we can replace half AB vector by AX vector. Then AX vector plus half BC vector equals what? Equals half AC, which is half AC equals AY vector. So we can say that we can move AX to the other side by negative. So we have half BC vector equals AY vector minus AX vector. But we knew that negative AX vector can be XA vector. If we reverse it, the direction, then we change the sign of it. So we can say that half BC vector equals AY vector plus xa vector. Let's try it here in the figure. Ay, that's direction of it, plus xa vector, like that, xa vector plus ay vector. That means xy vector, like that. Then we can replace ay vector plus xa vector by xy vector. We have started by x to a. Then from a to y, we have xy. Again, we have started xa from x to a, then from a to y. That means xy. The start, the beginning is x, and the final end is y. We will have xy vector. So we have here a relation saying that xy vector has that direction is equal to half bc vector, which in the same direction. That means that xy is parallel to bc but not equal to it. It equals its half by the proof. Then xy is parallel to bc, and xy equals half bc in it, and that is the required to prove. Let's move to the third problem we have here. Using vectors, prove that the two diagonals of the parallelogram bisect each other. To prove that, we have here to make a construction. We have here, and by given that the figure ABCD is a parallelogram, and also AC is a diagonal in it. And he gave me that M is the midpoint of AC. So we'll make a construction. That construction is to join M with B, then M with D, and try to prove that B and M and D are collinear. And that can be done by vectors if they are equal. So we will try to prove that Bm vector is equal to Md vector. Let's try it. We have here in the triangle ABM that AM vector, AB vector, sorry, AB vector plus MBM vector, that equals AM vector. And also MD vector plus DC vector equals MC vector. Let's start with this. Since we have a triangle ABM, then AB vector plus BM vector equals AM vector. And we have also DC MD vector plus DC vector equals MC vector. And well, since M is the midpoint of AC by given, that means AM vector is equal to MC vector, which is here. You see it? AM equals MC. Then we have here a relation. AB vector plus BM vector equals MD vector plus DC vector. But we have here another relation. AB vector here and DC vector. Let's see it in the graph. We have here AB have the same direction of DC, and they are equal and parallel because ABCD is a parallelogram. Since ABCD is a parallelogram, then DC vector equals AB vector. DC equals AB. So we can cancel it from here to here. Then what we find? We find that BM vector equals MD vector. That means that BM is parallel to MD, and MB equals MD length. What does it mean? If they are parallel and having a common point, A, BM, and MD are parallel and having a common point, then they are coincident. Coincident meaning that they are collinear. Then B and M and D are collinear. This means that BD is a diameter, a diagonal, and M belongs to it, to BD, and M bisects MBD. This means that the two diagonals of any parallelogram are bisecting each other. And we have here finished the requirement. That's a proof by vectors to one of the properties of a parallelogram. We have here another example, example 4. In the opposite figure, ABCD is a trapezium. It's obviously a trapezium in which AD segment is parallel to BC segment, and BC equals 3AD, 3 times AD. That means that BC is greater than AD 3 times. And also AD vector equals M vector, and AB vector equals M vector. The requirement is to express in terms of M and N vector each of BC vector and AC vector and BD vector and DC vector. Let's start with this. We have here BC vector requirement. Let's see it. BC vector by given, it has this direction, and by given BC vector, our BC line segment equals in length 3 times 80. So we can say that BC vector equals 3AD vector by given. And so we can replace AD vector by M vector. Then BC vector equals 3 as it was times AD vector, which equals M vector, and we have here BC vector in terms of M by the required. Also, he said about AC. Let's see AC. AC vector, that line, it shouldn't be drawn like that, but it is a construction to complete the other requirement, but we will consider AC vector. AC vector equals AB vector plus BC vector. If we have this direction, so AC vectors equals AB vector plus BC vector by shell rule of triangle. But we have here AB as an n vector, so we can substitute for AB by n vector plus BC vector, which we have deduced previously by 3m. We can substitute for it by 3m, and hence we have here AC in terms of n and m vectors. Also, he required BD vector in all sense. BD vector equals, let's see, BD that direction equals BA like that plus AD. BD equals BA vector plus AD vector. We have here AB vector equals N, but here it's not AB, it's BA. So we can reverse BAB to BA, then we can have n by the negative, so we have negative n vector instead of BA vector plus AD by given equals m vector. That means m vector minus n vector, and this leads us to represent BD vector by terms of m vector and n vector. That's its term here, and here. Last and finally, in one, he wants DC vector. Since DC vector equals, we have here DC vector in this direction. If you want it, we can say DC vector equals DA vector plus AB vector plus BC vector. So we have DA vector plus AB vector plus BC vector. We have started by D, going to A, then from A to B, then from B to C. That means the displacement covered is DC, and that's required. So we have here dA vector is the opposite of AD, which is negative m, plus AB vector, it coincides n vector, plus BC vector, which we have previously given by 3m vector. We have here two like terms, negative m vector and 3m positive 3m vectors. So we can simplify them by 2m vector. Then dc equals 2m vector plus n vector. And we have finally finished the first requirement. So we have here the other requirement, number 2. If x belongs to dB, he assumed that there is a point named x belongs to BD, such that xd equals 1/3 of xb. So we can have here that direction xd and xb vectors. So we will try two triangles to deduce them. First of all, we will try xb. xb vector equals xc vector plus cb vector. So we have, since xb vector equals xc vector plus cb vector, and also dx vector from triangle dxa. It can be dA vector plus ax vector equals dA vector plus ax vector. And let's see what we have got. We have said that ax 3 times equals xb. So we can replace xb by 3 dx. Then this one will be 3 dx vector. And that equals xc vector plus cb vector. But we have here dx vector equals dA vector plus ax vector. So we can replace this one by that one. So we have here 3 times dA vector plus ax vector, which equals xc vector plus cb vector. By distributing 3 inside the bracket to expand it, we have here 3 dA vector plus 3ax vector, which equals xc vector plus c vector. And let's try something. We have here studied that 3 dA vector equals cb vector. And since 3 dA vector equals by cb vector, then we can cancel these two from all sides. Then we have here xc vector equals 3 times ax vector. So let's see what we have. We have here xc vector equals 3 times ax vector. And that means that they are parallel, having the same direction, and one of them equals 3 times the other. So that means that x and c and a are collinear. Then xc is parallel to ax, and xc equals 3 times ax. Then a and x and c are collinear, and that is very important. A, x, and c are collinear. So let's see the next exercise. The next exercise is talking about if A equals 2 and 1, B equals 1 and 5, C equals 6 and -3 are the vertices of a triangle. Find by using vectors the coordinates of the point of the intersection of its medians. We have drawn here the triangle ABC in general case, and also we have here a midpoint of BC at D, and the point of intersection of the medians of the triangle is M. And we have a rule that states that this point divides each median into two parts by the ratio 2 to the 1 from the vertex, or 1 to 2 from the base. So we can use these definitions to find our sake. Firstly, we have here the point AM. So AM as a vector like that equals AB. Not exactly, equals 2/3 AD. 2/3 AD as a median. So we can get AD equals 3 over 2 AM vector. But we have here a rule of parallelogram which has a corollary saying that AB vector plus AC vector equals twice the median between them, AD vector. That means AB vector plus AC vector equals twice AD vector. We have here AD and here AD, so we can prove that AB vector plus AC vector equals 2 multiplied by 3 over 2 AM vector. So we have here a reduction. That means AB vector plus AC vector equals thrice AM vector. And let's start our job together. AB vector means B minus A, and that by given 1 and 5 minus 2 and 1. And that means point of 1 minus 2 negative 1, 5 minus 1 equals 4, and also AC vector equals C minus A. By the previous lesson, we have studied the operations on vectors in the previous lesson. So we have here C by 6 minus 3 minus A, which is 2 and 1, equals 6 minus 2 equals 4, and negative 3 minus 1 equals negative 4. So if we have to find AB vector plus AC vector, that equals negative 1 and 4 plus 4 and negative 4. And that leads us to get negative 1 plus 4 equals 3, and 4 minus 4 equals 0. We have that, which is that. And also we have here a 3am vector. So we have am vector that equals m minus a. That means unknowns a and b, for example, for m, minus A, which is 2 and 1. That equals A minus 2 and B minus 1. And since they have here that relation, then AB plus AC, we have it by 3 and 0. That equals 3 times AM, which is A minus 2 and B minus 2, minus 1 as well, sorry. So we are dividing here by 3 and here by 3. We have here A minus 2 and B minus 1 equals 3 divided 3 equals 1 and 0 divided 3 equals 0. So A minus 2 equals 1 and B minus 1 equals 0. That gives us A equals negative 2 will be to the other side by positive, so we have 1 plus 2 equals 3. B equals 1. Then the required point, which is M, equals 3 and 1 by vectors. That is the required. Example 6. In example 6, he gave us A, B, C, D is a quadrilateral in which A gives 0 and 1, B equals 4 and 5, C equals 1 and 4, 1 and 8, D equals negative 3 and 4. Using vectors, prove that the quadrilateral ABCD is a rectangle and find its perimeter and its area. So, how to prove that ABCD is a rectangle? To prove that, we should know two opposite sides are parallel and equal, and two adjacent sides are perpendicular. Let's try it. We have here AB vector that equals B minus A, and that equals B here is 4 and 5 minus A here is 0 and 1. So we can calculate it easily. 4 minus 0 equals 4, 5 minus 1 equals 4. Then we will try to draw the rectangle to find out how to prove it. That's AB in that direction and C. The parallel side is DC. So let's see how to find DC vector. That equals C minus D. And that means 1 and 8 minus negative 3 and 4. And that leads us to 1 minus minus 3, which equals 4, and A minus 4 equals 4 also. What do you notice? You notice that AB vector equals DC vector. And AB vector equals DC vector, and that means AB straight line is parallel to DC straight line, and also AB equals DC. Those two conditions mean that ABCD is a parallelogram. And ABCD is a parallelogram. But we don't know that it is a parallelogram. We want to make it a rectangle. How to do that? So we will calculate BC vector, and so we can find out the relation between AB vector and BC vector. Let's see. BC vector equals C minus B by the rules, and that equals 1, 1 and 8 minus B, which is 4 and 5. The result here will be negative 3 and 8 minus 5 equals 3. Let's try to apply on BC vector and AB vector. AB vector equals 4 and 4, and BC vector equals negative 3 and 3. We have studied previously the condition of perpendicular straight lines. That means if x1, x2 plus y1, y2 equals 0, then L1 is perpendicular to L2. Let's see if is that satisfied here or not. Here is x1 and here is y1. Here is x2 and y2. So we have 4 multiplied by negative 3 plus 4 multiplied by 3. That equals negative 12 plus 12. That equals 0. That is the condition. Then the first line, which is AB vector, is perpendicular to the second line, which is BC vector, and that means the figure is a rectangle, and that is the required. But he has required also its perimeter and its area. Perimeter of rectangle equals length plus width times 2. Let's see the length of AB vector. That equals square root of its magnitude, which is 4 power 2 plus 4 power 2. That leads us to square root of 32, which means 4 square root 2 length units. And also norm of BC vector, which is the width, that equals square root of its two components, which is negative 3 and 3, negative 3 power 2 plus 3 power 2. That's the rule of the norm. That means square root of 18. That equals 3 square root 2 length units. So the perimeter will equals 2 times 4 square root 2 plus 3 square root 2, which equals 4 plus 3 7, root 2 times 2 14 root 2 length units. And also the area here, the area equals length by width, which is 4 square root 2 multiplied by 3 square root 2, which equals 4 by 3 12 times root 2 by root 2 equals 2, which equals 24 square units. At last, we have here our final exercise in this lesson, which about ABCDs of quadrature, in which A given, by given, C given, D given. Using vectors, prove that the figure is a rhombus, then find its area. To prove it is a rhombus, we should prove that it is a parallelogram firstly. Then its two diagonals are perpendicular. Let's try it. We have here that rhombus, which is A, B, C, D. Let's try it. AB vector in this direction and BC vector. That means B minus A equals 3 and negative 2 minus 5 and 3. That equals 3 minus 5 equals negative 2, and negative 2 minus 3 equals negative 5. Also, DC vector equals C minus D, which equals negative 2 and negative 4 minus 1 and 0 and 1. And that equals negative 2 minus 0 equal negative 2, negative 5 minus 1 equal negative 5. That means that AB vector equals DC vector. So we can deduce that AB is parallel to DC and AB equals DC. Then ABCD is a parallelogram. But we can prove that it is a rhombus if its two diagonals AC and BD are perpendicular. Let's try it. AC vector equals C minus A. That leads us to say negative 2 and negative 4 minus A, which is 5 and 3. That equals negative 7 and negative 7. Also we have here BD vector. That equals D minus B, which is D here, 0 and 1, minus B, 3 and negative 2. Let's try its solution. 0 minus 3 equals negative 3, and 1 minus minus 2 equals 3. Let's try the previous condition of perpendicular lines. So if we have here x1, x2 plus y1, y2 equals 0, then L1 is perpendicular to L2. Let's try it. We have here x1 and y1, here x2, y2. Then negative 7 by negative 3 plus negative 7 by 3 equals negative by negative positive 21 minus 21, equals 0. Is required. Then AC vector is perpendicular to BD vector, and that is enough to prove that ABCD is a rhombus, and ABCD is a rhombus. Then, to find its area, we should know the lengths of the two diagonals, because the area of the rhombus equals half the product of the lengths of the two diagonals of the rhombus. So we have here the norm of AC vector, because we have it also already, negative 7 and negative 7, square root of negative 7 power 2 plus negative 7 power 2 equals square root of 49 plus 49 equals 98. That equals 7 square root 2. Also norm of BD vector, which equals square root of its components, negative 3 power 2 plus 3 power 2. That equals 18, which equals 3 square root 2. Then the area of the rhombus equals half multiply 7 root 2 multiply 3 root 2. That equals 7 by 3, 21. And root 2 by root 2 equals 2 times half equals 1. And the final result is 21 square units. That's all for today. I hope you have been useful for that lesson. And Assalamu alaikum.